Okay guys, last section of chapter 6, rational equations. So we talked about how to simplify expressions. Equations can sometimes be a little bit easier because as long as we know that we restrict our domain by things that can't be zero in the denominator, we can actually clear the fractions by multiplying by the common denominator instead of finding a common denominator, getting our fractions, and then having to do a lot of work with them. The only thing we have to be careful to do is possibly plugging back into the original to make sure that we're not dividing by zero, which we can usually do by restricting our domain in the first place, knowing that if any of those come answers, they're not okay. For now though, let's just practice some things with regular fractions with variables. Identify the following as expressions or equations, simplify or solve after. Number 1, if you don't see an equal sign, it is an expression. Simplify an expression, so I need to combine these. So my common denominator needs to be 40. So this is 7/8 needs to be multiplied by 5. So 1/5 x needs to be multiplied by 8. This is 35/40 x plus 8/40 x, which is a total of 43/40 x. Compare this to number 2. 3/5 z minus 7/10 z equals 1. See the equal sign? This is an equation. But same strategy, I need a common denominator, which in this case is 10. So I need to multiply the first fraction by 2. So 6/10 z minus 7/10 z equals 1. That is negative 1/10 z equals 1. Okay, to clear this fraction, I can multiply by 10 on both sides. 10 times negative 1/10 is just negative 1z. 1 times 10 is 10. Divide by the negative 1. Get z is negative 10. Equations usually have a number answer. Expressions, you're just going to simplify. You'll still have an expression when you're done. Okay, solve the following equations. Check your solution. I'm going to do one and let you guys do the other. I'll do number 1. A minus 3a over 2 equals 1. So there's a few options here. If you want to just multiply by your denominator to begin with, so multiply by the 2. It'll make your life a little easier. That means 2a minus 3a equals 2. Subtract negative a equals 2, which means a is negative 2. So those ones aren't so bad. But we're going to get into some where there's actually variables in the denominator. It'll be a little bit trickier, but if we've done 6.4, we can manage these, especially if we've done 6.4 and 6.2. So set every denominator equal to 0, solve each new equation, and write each answer as x is not equal to. So this is finding all values of your variable that make you divide by 0. So this is to kind of check yourself to know which values of x you can't have at first. So x is equal to 0, x minus 3 equals 0, x plus 1 equals 0. And these are all things x can't be, so we could put a not equal to 0 and still treat the equations the same. Add 3 to the other side, x can't be 3. At minus 1, x can't be negative 1. So what this is really saying is that x can't be 0, 3, or negative 1 because it would make one of our equations divide by 0. Now, if you've got some equations that need to be factored, you factor everything first. I mean, you can set the denominator equal to 0, but I would factor. So two numbers that multiply to negative 9 that add to 8 is x plus 9, x minus 1. X squared minus 4, that's the difference of squares. It's x plus 2 and x minus 2. So you set all of those equal to 0. So x plus 9 can't be 0 because that would make this 0. X minus 1 can't be 0 because again it would make the first fraction 0. X plus 2 can't be 0, and x minus 2 can't be 0. Now if x plus 9 can't be 0, that means x can't be negative 9. X minus 1 can't be 0, that means x can't be 1. X plus 2 can't be 0, that means x can't be negative 2. If x minus 2 can't be 0, that means x, again, can't be 2. So these are the 4 numbers that x cannot be. They may have you put that in a solution set, but I wouldn't normally. So now let's see what happens when we have an equation with variables in the denominator that we have to solve. So 2x plus 3 over x equals 3 halves. So what's my common denominator here? It needs a 2 and an x. I multiply everything by 2x. Let's see what happens. In the first fraction, the x's cancel, so I get 2 times 2x plus 3. The second fraction, the 2's cancel, I get 3x. Distribute, so 4x plus 3 equals 3x. Subtract 3x, 4x plus 6, excuse me. Subtract 3x, x plus 6 equals 0. Subtract 6. X can't be, or x is equal to negative 6. We need to check, though, and make sure. If I plug in negative 6, doesn't make any of my denominators 0. It looks like the answer is no. This denominator would be negative 6. This one's 2 no matter what, so we're fine. Let's try this again. 3 over k minus 1 plus 2 over 4k minus 4 equals 7 fourths. So this factors into 4 times k minus 1. So my common denominator needs to be a 4 and a k minus 1 to get rid of all of the denominators here. When I multiply all of these by 4 times k minus 1, the first fraction has the k minus 1 is missing the 4, so it'll be 4 times 3. The second fraction has both the 4 and the k minus 1. They will reduce to 1, and the only thing that will survive is the 2. The last fraction has the 4, doesn't have the k minus 1, so the 4's reduce, k minus 1 times 7. This is 12 plus 2, so 14 equals 7 times k minus 1. You could distribute here, but I'm going to divide by the 7 instead. So 2 equals k minus 1. Add 1. K equals 3. Now you can plug this back in to make sure if you want. It would be 3 halves plus 1/8 equals 7 fourths. Sorry, 3 halves plus 2/8 equals 7 fourths. But most importantly, does 3 make this denominator 0? 3 minus 1 equals 2? No. 4 times 3 is 12. 12 minus 4 is 8. Still no. And 4 is still not 0. So k equals 3 should be a fine answer. And we'll finish this up in the next video.